Okay, welcome back to the April 7th study hall. We've got one more day of inequalities because they've been such a hit the last couple of sessions. And we just went through the rulesy stuff and back to the copyright attribution screen. These are from the free GMAT prep software unless otherwise noted. So there we go. Okay. Let's do one. How about this one? Remember, when you have multiple choice questions, please indicate those choices in the right place. This is data sufficiency. We do assume that you have a certain degree of familiarity with the data sufficiency answer choices. So this is data sufficiency. All right, give it a shot, please. Yeah, you're right. You can't hear anything because you are still working on the problem. I'll give you about another 30 or 40 seconds or so. All right, let's talk about it. A lot of people still don't have answers to this, so you should pick something. Mike, the question is how long do you think it gets you questions? I mean, I give you enough time to do the problem a little bit more than you typically need, basically. I like this problem because the people who are answering at the end are the ones who are actually getting it right for the most part. Like here's, I don't normally show answer distributions, but here's the answers. Here's the people that picked so far. There's still a lot of non-answers, so you guys should pick something. So the nature of this test, you can't not pick answers, but there's 15 non-answers at the bottom. Most of these people, this is a wrong answer. It's not E. I mean, most of these people pick right away. Like most of these came in the first 30 seconds. And that's incorrect. The answer to this problem is not E. So, okay, if you don't know what data sufficiency is, then I mean, what I can do is I can get the choices out of I can get the 5 data sufficiency answer options out of the book and just paste them onto the board. And you can see if you can follow that. Unfortunately, I can't actually take the time to explain the data sufficiency format completely, but I can at least post the answer choices onto the board, and you can try to follow from there. When we say an answer choice is sufficient, what that means is that there's enough information to give a unique answer to the question. In other words, sufficient means that there's one answer and only one, and not sufficient means there's 2 or more. So that's what all these answer choices are all about that you're going to see. So beyond that, they usually just take some getting used to. So, and these workshops do assume a certain level of familiarity with that. So that's what the answer choices mean for this format of problem. So I guess try to just follow along with that as best you can there. But okay, Anyway, the answer to this is not E. And if you picked E in the first 30 seconds or so, then you should reconsider the amount of reasoning related to that. But, okay. Let's talk about it. Okay. So when you think about these problems, what's neat about this is how much, like the statements have to say about each other. Like statement 2, for example, says that A is an integer. Like when you see this, what does this mean that you should immediately start thinking about when it comes to statement 1? Like if they're talking about, yeah, you should think about things that aren't integers. Because again, I don't know what ace means, but okay. So if you've got, like if this is saying that A is an integer, then what this means is that it probably matters when you specify this. So this means for statement 1, you should also think about non-integers. And in general, when you have restrictions, when you have statements like that that put restrictions on stuff, that means you should pay attention to them, but in general, it means you should also be paying attention to, like, not putting the same restriction on the other statement, right? So when it comes to things like statement 1, I mean, this is also kind of an interesting looking algebraic expression here. I mean, this is something we can factor if it helps us. You can't pull out an A to the N out of that. I mean, you don't have to, but you can and just kind of see what comes of it. So that gives us A. If you pull out an A to the N, then that gives us 1 plus A. Okay. And that's less than 0. Let's see what the deal is there. So when is a product of two things negative? I mean, like you have this thing and that thing. You have this orange thing and you have this blue thing. And those are supposed to be a negative product. Yeah, it means that one of them is negative, but not the other one. So, I mean, you could go about doing this in one of two ways, right? You could just try to find cases where this happens. Or you could think like strategically about this kind of thing, about trying to make that positive and that negative, and then turning around to try to make that negative and that positive. So, I mean, let's try to do that. Let's see if we can do that with strategy kind of thing. So, I mean, we probably the more obvious way to do it is to do what Abby is saying, which is that you can make the A part negative. So, then wait a minute, what about the 1 plus A? Well, that's interesting. So this is written down. So this could be negative times positive times positive question mark. Or you could also have I didn't even move that. Or you could also have the orange part be positive, and you can have the blue part be negative. Well, how can we get this to work? So if a to the n is negative, then what do we know about n? And what do we know about a? If we're looking at this condition right here, yeah, we would know that a itself would have to be negative. And then n has to be odd. Because if n was even, then that would turn the orange part positive. But then 1 plus a would have to become positive, which means that a has to be a fraction kind of thing, right? So this would have to be something like, a could be negative 1/2, and n could be, n could just be something like 1. I mean, this is the kind of thing you might just happen upon if you were experimenting with numbers for the first part here. You could also just think about it for the first part as well. Where this would be 1/2 to the 1, negative 1/2 to the 1, sorry, close, negative 1/2 squared. So this would actually wind up being negative 1/2 plus positive 1/4. And that would be negative. So that would work. So in this case, n is odd. Yes, n is odd in that case. On the other hand, if you look at the opposite type of case, and if you come up with anything that does that, then n is going to be odd. But if you look at this other type of case, if you want a to the n to be positive, but you want 1 plus a to be negative, then if you want 1 plus a to be negative, then a is definitely negative. And then if you want a to the n to become positive, then n is going to be even. So a could be something like negative 2, and n could be like 2. And no, n is going to be not odd. So if you check the numbers here in that case, then you would have negative 2 squared is 4, plus negative 2 to the third is negative 8, and that would become that. Can you take it out of the equation? What do you mean take it out? Well, my wonderful internet is being wonderful as usual. I'm not sure what was the last thing you heard me say, but all the things I wrote in the board are still there, luckily. So we have these two cases that both work, one of which has n odd, one of which has n not odd. I saw Jeremy saying, can we take something out of the equation? I'm not sure what that means exactly. So what does, Jeremy, what do you mean by that? You take it out. What do you mean take it out? No, you mean try to divide by it? I mean, you can't. I mean, you probably know that you can't do that because if you think about a simpler example, then it should be pretty clear that you can. Like if I tell you that x, y is less than 0, then it's probably pretty obvious that you can't just say that x is less than 0. Like, you can't just take out the y. So, and what you're trying to do is exactly equivalent to that. It's not a thing. So the reason why you can't do that is you're not allowed to divide by y because you don't know the sign of it. You don't know whether it's positive or negative. But the most important, if it were negative, you'd have to flip the inequality. If it were positive, you wouldn't. And if it could be 0, then you wouldn't be allowed to divide by it at all. But the more important part of that is the fact that you don't even have to ask the question because you can just think about a simpler example. Like, because, the fact that these are called a to the n and 1 plus a is not even important here. It's not. It doesn't matter that they are 1 plus a and a to the n. It's the same thing as if they were x and y. And so then you can just figure it out like that. So, okay. All right. Yeah, which is always the goal, right? I mean, the goal in every single yes/no type data sufficiency problem ever, all the time, is that. Exactly, right? I mean, the goal is to get a case that corresponds to yes, it is, and another case that corresponds to no, it's not. And you try to prove not sufficient. Right? So there's this kind of device that we've talked about setting up for yes/no type of data sufficiencies in these other sessions before. So we might as well set it up again, right? So yeah, that's always the goal of every yes/no data sufficiency problem ever. Absolutely. So yes, and is odd. No, it's not. And then you can say for statement 1, statement 2, and then if you combine them for both. Yeah, and that means you have not sufficient for statement 1, exactly. So, all right. So this means not sufficient. That's what it means. I mean, this kind of device is your best friend when it comes to this sort of thing, right? Because it puts the goals in front of your face. I mean, you can make this kind of device just based on that question, is n odd. So you don't even have to read the rest of it in order to do that. But just setting this up will keep you grounded, and then that's what you're trying to do. But anytime the question is yes, no type of question, you can pretty much always do this. So yeah, that's the goal. Okay, cool. So Mike, if we're clear on that. All right. For statement 2, we only know that a is an integer and n is an integer, and they are not 0. So, but at least the presence of this statement should have, when you consider the other statement, should have just been a kind of kick in the brain to make you think about stuff like that. Right, because if you weren't thinking about those kinds of numbers, this should have reminded you to do that. I mean, by itself, statement 2 is going to not work. I mean, statement 2 by itself is definitely not sufficient. So, because if you all you have is statement 2, if you have just that alone, then you have, well, what we have a is an integer, and then we have that n is an integer. And then the product is not 0, so neither is 0. That's all we know. So definitely could be either way. So that's going to go both ways for sure. So that's not sufficient. So I combine them. But if we combine them, if we combine the statements, then, and I mean, you should kind of think about it and if you're going to really try to be a ninja with this type of stuff, if you specify that something's an integer, like if I had 5 seconds to guess this problem, I would guess C. And the reason why I would is I would look at this and I would be like, I bet that like blah, 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 blah is probably like, I bet this works out 2 ways. One way if it's an integer and another way if it's not. And then I bet that like if you make it an integer, then it rules one of those things out. That's at least how I would guess, right? Because I mean, if I was writing this question, there's just no other reason why it would occur to me to write a statement that said this. You know, like if you imagine, if you put yourselves in the mind of the question writer, a lot of this will make sense. I mean, it's like the only circumstance under which you would think to write this statement would be if it did what it's going to do here. It would be if it narrowed something down to the point where it solved it. So if you had to do that, if you had to guess, you had like 5 seconds, boom, I have to guess this. But yeah, because okay, if you combine the statements, if you think about these 2 cases that we have listed up there, let's just reproduce those here. There's those 2 cases from upstairs. If you've got, I mean, the problem with having A be negative and 1 plus A be positive, remember that's what we're talking about. The left-hand part is A to the n, and the right-hand part is 1 plus A. I mean, the only way that you can have A negative and 1 plus A is positive is that this would have to be fractional. And so if A has to be an integer, then that case is going to be ruled out. Right? This isn't going to be possible anymore. And I mean, you could also just do that by just experimenting with numbers. I mean, you really don't have to think all the way through that if you are aggressive enough about just trying numbers and trying more numbers and just like throwing tons and tons of numbers at the problem. If you just do that, you just do stuff and you don't not do stuff and you just toss numbers at the problem, you'll eventually discover that only fractions can make that work. So I mean, if you combine the statements, like if A can only have integer values, then this is impossible. Then this case is not possible. The other case is still possible, of course, because something has to work. But this case no longer flies. So there you go. And so you're left with the other case where you got to be even. Because this is going to be negative, which means A is negative, and the way to make negative to the n become positive is if n is even. So n is going to have to be even. It's the only way it's going to work out. So n won't be able to be odd. It's going to be impossible to get n to be odd. And it's going to have to be even. It's going to be sufficient. So this is C like cat. Any questions about that? All right, let's do another one. How about this one's from the GMAT prep software. How about this one? Give it a shot. You know where you find those multiple choice answers. You know where those are. Those are located right there. This one actually is multiple choice. I'll give it a shot. Alright, I should wrap this up pretty soon. Picking something. Give me 20 seconds or so if you need it. Alright, let's pick an answer, please. Still a bunch of people who have it, especially for some reason, the end of the alphabet. There's like 5 people right at the end of the alphabet who haven't picked an answer yet. So there definitely shouldn't be an almost there either, because there's just no reasonable way that you could still be working on this. I mean, I don't mean to be a hater or anything, but there's not really a work process flow that could take this long. I mean, like a big part of this test is that too. I mean, like the GMAT is a test of decisiveness, almost above all else. I mean, it is. They are trying. They've actually written this before. The people who make the test have written this. They've written that they want to reward decisiveness and punish perfectionism. Like they've actually written that on their official blog, because that's kind of what business does too. I mean, yeah, think about how business works. I mean, getting to market first is also much more important than making a perfect product, for example. So, but I mean, on this test, you definitely have to just get an answer marked. And I mean, if you have a process that has more than like 3 or 4 steps in it, then your process is basically wrong. Because that's how these products work. So, and I mean, when I say steps, I mean steps like, think about tying your shoes. When you're a little kid, tying your shoes is like 5 steps, and when you're an adult, tying your shoes is 1 step. When I say steps, I mean like that. If you call tying your shoes 1 step, in that sense, if your process has more than about 3 steps, your process is wrong, and you should just stop what you're doing. So, yeah, reciprocal means you flip it over. So, yeah. This is important because you just have to have this honesty with yourself about what is going on in the problem and like whether you are really headed towards something or not. So, but yeah, reciprocal is when you flip something over like that. So let's talk about it. So what we know that n, we know that n is to the left of 0 number line, which means that it's what? We know that it's negative. Yeah, we know that. And then, so n is negative. And the square of it is less than 1/100. Okay. Cool. And then we just know they're asking us a question about the reciprocal. Well, so we have this, right? N squared is less than 1/100. N squared is rather not n. Okay. I mean, what does this mean that we can do? Like, this is all the information that we have. Is this enough information to find a unique value of n? Like, is there going to be only one value? Definitely not, right? There are lots and lots and lots and lots of ends that do this. So what does that mean we can do? Like, whenever there's like lots of different values that do stuff, we can just pick one of them. I mean, we don't have to find the entire range. That's the entire point, is there'd be no reason to bother doing that, because there's no point. I mean, there's one correct answer to this problem, and every single number that does this has to get us to the same answer. Because, I mean, it's impossible that any of those numbers could lead us to the wrong answer, because otherwise the problem would have to work differently. So, you know, because yeah, well, let's just, I mean, because again, we don't have to put an entire range on n. We just have to find some number that will do this, and then it'll be good enough. I mean, when it comes to reviewing the problem, that's when we can try to put entire ranges on n, sure, but we just need to pick one of them, dude, and we're good. So a negative whose square is really small. Okay. Can someone give me a negative whose square is really small? 1. Negative 11, the square of negative 11 is positive 121, which is definitely not less than 1/100th. Yeah, how about like a tiny, yeah, you guys are good at it with really small numbers, sure. Small numbers. Like how about negative negative 0.01, sure. So then n squared is positive 0.0001. That's definitely less than 1/100th. So that works. Satisfies the condition. So then we can just use this value. So the reciprocal of n in that case is negative 100. So the reciprocal is way less than negative 10. There you go. That does it. How about that? And if you come up with any specific value of n, then the reciprocal will do that. I think all you have to do, all you got to do is find one value. You're good. Because, yeah. I mean, also, the other thing about these problems is there are, like, all these little clues in the problem, like, because remember, there's no deception on this test, and there's no tricks, and there's no, like, underhandedness of any type. Like, when you see if n denotes a number that does this stuff, you know that even that right there is a hint that you can do this, because that means that n is a number that does that, meaning there's more than one. Like, it's not the number that does that. Like, it's not the only one. Right. So, but notice this is not some long and involved process with lots and lots and lots of steps. I mean, if you were somehow still doing something after like 2.5 or 3 minutes, then whatever you were doing, it was definitely not productive, and it definitely had not been productive for a long time. And that's the kind of thing that you just have to be honest with yourself about, and people are not good at being honest with themselves about that, and it's just you have to. Where that comes from is partial credit in school. I mean, partial credit is I'm not talking to any one person. This is the biggest problem that people have on this test. I mean, because partial credit has convinced people that they should just keep working beyond any time limit without knowing where they're going with this. And I mean, if you think about driving somewhere, like, and you get lost, then you know exactly when you're lost at the instant when you become lost. You know exactly when you become lost, and you stop. You stop right then and there. And there's a moment, and it's a distinct moment in time when you become lost, and you know what it is. Or if you're like putting together a piece of furniture that you bought at a store, you know there's a point where if you don't know where the next piece goes in that piece of furniture, then you know where that is. Like you're like, oh, I don't know where this next piece goes. And there's a distinct point where you become lost putting the piece of furniture together. And it's a distinct moment in time. So, yeah, but it's only in this kind of taking tests environment where people lose that and they just kind of do stuff without that sense of purpose. And where that comes from is having been rewarded with partial credit for so long for doing that. But yeah. Okay. So anyway, just be aware of that, because that is a big part of what this exam is, and that is what the test is made to do. So, yeah. All right. I was one for a long time. You can use decimals too. You can also convert these into decimal form. Let's see what else is going on in these comments. Let's see. If you what else? You can also use decimals. Yeah, you can. We were using decimals here. You can use fractions. Okay, fractions are easier. If you find fractions easier, then you should use decimals when you review. If you find decimals easier, you should use fractions when you review. The goal of reviewing the problem is when you should always work on things that you like less, so that you can round out your skill set and so forth. And that's play, right? It's kind of like you're an athlete who is very strong and very, very fast, but not flexible. Then you would want to go stretch more. That whole bit. Cool. Are there any other questions about this problem? Okay. And incidentally, if you do the general solution to that, like the reason why, okay, like if you wanted to actually solve that in general, which you don't have to do, but which you could do as part of a review process of whatever stripe. If you wanted to solve that in general, then you would you have our n squared is less than 1/100. So that means that n is, first you have the sign problem. That's the first issue there. You have n squared is less than that squared. So that means that n itself is going to be less than 1/10, but also on the other side of that. You don't deal with that with this problem, but when you review, like if, for example, this would probably be easier to think about with integers. Like if you had n squared is less than 64, for instance, this is probably not as obnoxious to think about. You probably know that means this. So if you do that, this is why it's important for them to tell you that n is negative. But then this is where they get into the whole reciprocal thing, because then when they go into reciprocals, right, like if you have these, if you think about this on a number line, it might be a little bit easier. Like here's your number line. Let's say we drew that. Number line. Number line. Because when you talk about reciprocals, you have to imagine that the number line has this big gap in it where it doesn't. Like you have to imagine there's like a big hole in the middle of the number line at 0 right there. Because so here, let's just put a little notches there for a -1/10 and +1/10. This would be -1/10. And this will be +1/10. So then you've got these two areas here, and these areas have those two different kinds of reciprocals. Like the numbers that are in this area are going to have reciprocals that are between -infinity and -10, which are the solutions incidentally of this problem. Between -infinity and -10. And then these ones which are ruled out of this problem are going to have reciprocals between 10 and infinity. So there you go. All right. And which is, again, thinking about this during, if you thought about all this during the problem, then that would just be that'd be a mistake, because you just don't need to think about all this to solve the problem. This would be too much thinking to solve the problem. But thinking about this during review would be absolutely appropriate, because any of these things could be certainly appropriate in some other type of context. Okay, well, that escalated quickly. All right. But no, in general, like seriously, time management, guys, is just making sure that you are on task and headed towards a goal that is definite. Like driving somewhere, you have to know that you know where you're going and that you are not lost, and so on. I mean, that's the purpose of this test. It is what it is. Partial credit. Okay. Anyways, let's do the problem. That was actually kind of funny. That was unexpected. Okay, let's do another one. How about that one? Data sufficiency. So here are the current responses. There's a lot of people with this one, and I don't know if it's just because you think that you see a lot of the same things that you think you see here. I mean, if that is what this is, because a lot of the people who are picking that choice picked it really quickly, and if that was the reasoning behind that choice, let me just kind of make you think about that twice. Like if your reasoning was, hey, I saw a lot of the same stuff. I mean, this is not a good kind of reasoning. You should kind of suspect that because, they want you to actually, solve the problems. They want you to not just see things. They want you to, do things with things. So you should be suspicious of that. But, yeah, so the answer is not B. But give it a shot again. Yeah, this one's not super easy, but we know that the answer is not B, at least. So there's still 2 of you who have B, which means you shouldn't have. So I didn't technically say it's not D, but that's a good look at. I mean, you should extend that to thinking this probably isn't sufficient in general. Yeah, I mean, right. Okay, let's do it. Okay. Well, so some thoughts about this statement, because again, if you're gonna be guessing on this, if you don't have an answer choice, by the way, you should pick something. This is remember, you can't not pick a choice on this test. So this is statement 1. Does statement 1 says B is an integer? Statement 1 doesn't say that. You guys are looking at the right screen, right? Hmm? I'm afraid that, wait a minute. Somebody wrote this in the chat box. Statement 1 are you guys all seeing the same problem on the screen? Like statement 1 just says the absolute value of B is greater than 1. Is that what you see? Okay, so we're good there. I mean, this has nothing to do with integers. If you think about integers in this problem, it shouldn't really change anything, but it just means that, this just means that B is more than 1, or it means that B is less than -1, but it doesn't, if you only thought about whole numbers, then it wouldn't really change anything, because, it rules out the numbers that people traditionally think about when you say decimals, which are the numbers between 0 and 1. I think that's kind of what you are probably thinking about when you say that. But maybe maybe someone is even thinking that that integer just means something that's one or more. I mean, you never know. Like I've had some students who've not known what terminology meant, which is fine because you don't really have to know terminology all the time. But yeah, but no, these don't have to be whole numbers. So okay. Anyways, but we are all looking at the same problem, at least. Yeah, same problem for it. Okay. So when you look at statement 2, you should think two things. I mean, the first thing you should think with statement 2 is you should think, I bet this is not sufficient because it looks too eerily similar, right? Like you should think probably not sufficient because it's too similar to the question, like it's too good to be true. But at the same time, it's probably not useless. Like you're probably going to do something with it. Because, it's like, why would they go to the trouble? So, So if you had 5 seconds to guess the answer again, maybe you could guess. But let's talk about it. Like also, this is probably not random either. Like this whole absolute value thing. Meaning, like, what the heck is that? Well, that's probably not something necessarily random. I mean, you might not know what it is, but it's probably not nothing. It is, this problem is not super easy, but you should approach it like you approach anything else, which is just start hacking at it and see what's going on. Okay. So let's take a look. If you need, there's a couple people who haven't answered it. Statement 1 tells you that B is not correct. Yeah, it tells you that, so absolute value statements, this kind of thing would be useful for a flashcard. You can also think of the absolute value as like the size of a number, like how big is it without thinking about sign. Like it's positive or negative, but it's that big, right? So like it's either positive or negative, but bigger than 1. So it's more than negative. It's more than positive 1 or more negative than negative 1, so to speak. So is another way of looking at it. But the statement means that you could either be over, I should make those hollow circles, not closed circles, because you can't be, you actually can't have those values. So you could be, absolute value B greater than 1 means that you could be more than 1. Or you could be on this side of negative 1. That's correct, but it does rule out those things that people think of when they say fractions. I mean, you could still have fractions of the kind of like, you could still be like 12 fifths. But when people say fractions, that's not normally what they're thinking about. So, but yeah, the fractions that are between negative 1 and 1 are ruled out, yeah. Okay. So that's what that means. And like this would be an excellent flashcard recognition because this is now, you can't really solve this. So this is the kind of thing that you would want to put on a flashcard for instant recognition. Because you kind of have to be able to do it by recognition. So, like I'm not, you know what I mean? It's just you kind of just have to know what that is. The size of the number is more than 1. Okay. Let me know if that helps. All right, so but let's go to the original question for a second. I mean, like, what's even happening with this question? Yeah, and I mean, flashcards are great. I mean, I still use flashcards for all sorts of stuff in life, like anything that needs instant recognition. I mean, they're a pretty awesome thing. Does anybody have any associations to make with this? Like, when could, I mean, you might, multiplying and dividing, right? This is A multiplied by B and A divided by the same number. Oh, well, be careful with manipulating the inequality, because if you do that, you can't multiply by B unless you know the sign of B, and you can't divide by A unless you know the sign of A, which we don't know either of those. So, in a whole other fraction. Okay, so one of those things, right? Yeah, you are going to want to consider number types, right? Because like when you think about, normal integers and stuff, I mean, when you think of multiplying by B, you're going to think of always being greater than dividing by B. But, you have A times B versus A divided by the same B. Like, I mean, how could this be bigger? How could how could you make the right-hand one bigger? Like, I mean, how might this not be smaller? Yeah, it could be a fraction. It could be like a decimal or like less than 1. Or it could be negative. Yeah, Donna mentioned fractions. Nia mentioned fractions. It could just be 1. Yeah, right, it could be negative. Basically all those times when statement 1 is false, right, it could be negative. So this is a start, right? So now you see why statement 1 is relevant, because it's going to start ruling these kinds of things out. And or statement 1, because these are all things about B. B could be these things. Or A could be negative, which would reverse everything. Because if A is negative, and all of that's going to be screwy, everything will be backwards, right? So, absolutely, right? So let's take this to a new page. So let's do that. Also, this is a yes/no. So let's make that device that we make with these kinds of things. So the yes type of situation here would be the yes type of situation would be if AB is actually greater than A over B. And the no type of situation would be if AB is less than or equal to A over B. So there's our device. Statement 1, statement 2, and both. Okay. And remember, just to keep yourself grounded, it's amazingly effective to make this device. I mean, I would do it for I know that I say this every time we do a yes/no question basically ever in life, but it just, as far as keeping the goals in front of your face, like nothing does a better job of keeping you grounded in what the goals are. So this is the yes to the original question. This is the no to the original question. If you can make them both happen, then you can make it not sufficient. Okay, so if statement one, right, I mean, statement one, A can be anything. So we noted on the previous page that if you make A negative, it'll just make this backwards. So like if A is, I don't know, 3 and B is 2, then 6, 3 times 2 is greater than 3 over 2. 6 is greater than 1.5. That's true. So that is check mark in the top box. But then if you just make A negative, then that's negative 3 times 2, negative 3 over 2. So negative 6 is greater than negative 1.5. That's not true. So that checks out the bottom box. It's not sufficient. Statement 2, I mean, what's the deal with statement 2? Can any of you guys, statement 2 is kind of obnoxious, but can any of you guys make that less obnoxious for me? Jorge, I would actually argue that that made it a little bit more obnoxious, conceptually speaking, at least. Let me give you a hint. When is this positive? Because actually statement 2 has nothing at all to do with the question. It's kind of interesting how it doesn't. When is AB positive? Yeah, when the signs of A and B are the same. When is that positive? Oh, hey, whoa, it's the same thing. It's exactly the same thing. So these are two things that are positive under exactly precisely the same conditions. So there's no reason to factor it or do any of that fun stuff. You can just be like, oh, dude, well, since both of these are positive at exactly the same time, this is just whenever either of these are positive. So this is just a really obnoxiously stupid way of saying that A and B have the same sign. So, whereas the question isn't, because the question is actually comparing those things to each other. This is notice these are not actually related things. So interesting how that works. But this is just statement 2 is just a really, really annoying way of telling you that, of saying that both positive or both negative. That is correct. I mean, it's really redundant and really awful way of saying that, but it's all it's doing. So, okay, well, so these are both positive. So we can repurpose that and check off the top box again in the statement 2. But then we can do down and notice we could use fractions and stuff so we could do that, right? We could reuse this for statement 2. But then for statement 2, we can also use something like A is 3 and B is 1/2. Okay. So 3 times a half is greater than 3 divided by 1/2. So 1.5 is greater than 6 is false. So we can check that box. So not sufficient. This problem is not easy, but again, difficulty level is not a thing that is ever worth thinking about. I mean, every problem is your friend. The x's, I mean, you can check off the boxes wherever you want. When I'm doing the devices, I generally use an X if you can't make that happen. So I like to stay consistent with that. With the way that I'm using this device is this work would be somewhere else on the paper, and then this just gets checked off if you make those things happen. But this you don't like this is not a place to do the work itself. This is just a place to mark off if you have achieved these or not. So it's important to not do the work in the same place so that you know that here's what I've achieved, here's what I haven't achieved, kind of thing. And you keep that as a thing. If they're both negative, then it's the same. I mean, it's the same as considering 2 positives. If you look at what happens here, this is just A times B and A divided by B, so you'll get the same numbers. Obviously, you'll get the same numbers that you would get if you plugged in 2 positives. So, I mean, you could do that. It would just give you the same thing as if you threw in 2 positive numbers. Okay. Okay, so we're on the same page there. All right, so we got to combine the statements. Well, together. Alrighty. So together, here's what we know. Together, we know that A and B have the same sign. Both positive or both negative from statement 2. And we know that B is, like the size of B is more than 1. B is more than 1 or less than -1. So the deal is, if you consider these 2 quantities, if you consider the AB versus the A over B, and if you have to plug in numbers to figure this out, if you look at these 2, if you just look at these expressions, AB and A over B, since B is a number that is more than 1, and I mean, if you have 2 negative numbers, it's going to be the same as using 2 positive numbers. So just think about using 2 positives because it's conceptually easier. I mean, it's, using 2 negatives is the same. So just think about 2 positives. Sense the same result as 2 negatives anyway. So, I mean, if you use 2 positive numbers and one of them, and B is more than 1, then multiplying by a number that's more than 1 will make it bigger than A. So this becomes bigger than A. And this is going to become smaller than A. So, and they're both positive too, because they're both quotients and products of things that have the same sign. So this is going to be bigger than that. So this is always going to be a bigger product than quotient. So that's going to work. That's going to not work. And that's going to be C like cat. That's going to be sufficient. Cool, good stuff. And I mean, if you play around with numbers, you'll figure this out. I mean, once you figure out what's happening with statement 2, and like even with statement 2 is obnoxious and annoying, but if you just throw numbers into statement 2, you will very, very quickly figure it out. Because like if you throw in a pair of opposite sign numbers, then you will like really quickly notice that both of these go negative. And if you throw in 2 negatives, you'll very quickly notice that both of them are positive. And if you throw in 2 positives, you'll very quickly notice that both of them are positive. Like if you don't know what statement 2 is doing, then if you just start playing around with numbers, then you will very, very, very quickly, like. So in other words, I mean, it's kind of like those comments that I was saying before in that one problem. About like really you cannot keep pursuing threads that go nowhere. Like if you start doing stuff, like a couple people were doing fun things like this. I mean, some people here, let's take this to a new page. Here, statement 2. Some people were doing fun things like these things. And I mean, someone even wrote like 3 of these little symbols, which I'm going to assume that these 3 symbols means I did a lot of steps. I'm going to assume that's what that's supposed to mean. And that's exactly what you are not supposed to do, guys. Don't do it. Like really, really don't do it. I mean, you should be impatient. You should be very restless. You should not have patience. You should not have perseverance. You should give up quickly. That's the key to success on this thing. Really, it is. I mean, if you do not see exactly where this is going, then you should not keep messing with random lines of reasoning. I mean, because again, if you just start testing numbers. Because again, if you start throwing numbers into that statement, you're gonna figure it out really quick. I mean, you're gonna see it. If you start throwing in 2 negatives, you will see that it will work every time. And if you start throwing in opposite sign numbers, you will see that it never works. I mean, it will be really, really obvious really quickly. So that's the point. You just need to stop. You just need to stop doing things that are not working. So, okay. Alrighty, that's it. I mean, 2 minutes, guys. 2 minutes is an average. I mean, averages are averages. Averages are not limit. The point of averages is that there are just as many things over the average as there are under the average. Yep. I mean, it's interesting. I mean, this is always interesting to me, especially because this test tests averages. I always found that ironic. I mean, this is a test that actually tests the concept of an average, and yet we have people like, I can solve every single problem in under 2 minutes. Guys. No, you don't. But I mean, remember that you don't need to, you shouldn't even be thinking about this. Like, honestly, okay, here. I mean, as far as time management goes, just keep this in mind. I mean, you guys know how, no, it's C. It is C because if you have both statements together, then the left-hand side is always bigger. Can't have them equal each other because you have times something and divided by something. You have bigger and smaller. Here's a thought experiment, and like we are kind of over time here, so we have to cut it here pretty soon. But if you imagine, you know how like soccer works, where nobody knows how much time is left except the ref. Like there's no clock on the scoreboard, and like no one has any idea how much time is left in the game. Yeah, football in some countries, right? If you walked into the GMAT and they told you, okay, hey, there's been a rules change today, and that's how it works, and like there's no timer, and you will have no idea how much time is left. If you have good time management, that should not bother you even a little tiny bit. Like if they told you there would be no timer shown to you at all, ever, and you just had to go in there and take the test. Like if that would even bother you, that means your time management is bad. That's what it means. Because time management is just, am I stuck or am I not stuck? It doesn't mean I need to be thinking about minutes and seconds ever. It doesn't mean I need to be looking at timers. I mean, it just means I need to be honest about stuck or not stuck, and I need to not do work if I don't know that I have a goal. So just keep that in mind. That's all the time management is. It's kind of like driving car if you're sort of late somewhere. If you know that you know where you're going, you just keep driving. If you are lost, you pull over, and that's it. So it's a thought experiment. If they take a timer away from you, you should not care. If you would care, that means your time management isn't good enough yet. And if you do look at a timer, looking at a timer should be sort of like checking to make sure that your doors are locked before you go on vacation. Meaning it should never really be necessary. It should just be something that you just do as like a ritual. You know, just the doors are going to be locked anyway, but you just do it. Kind of like that. No, 1/2 divided by 3 is 1/6. So if you use those two numbers, the right-hand side is 1/6. All right. Not sure what you are Jesusing in response to, but okay. Anyways, let's kill it. Let's kill the time. The answer is bats. The answer is C, like cat. Sufficient with both statements. Alrighty. Alright, we are way over time here, so let's knock it. Let's kill the recording. Good afternoon, good evening, good night. Like we actually have the next session 1 week from today, which is it's not usually that close together, but there are some scheduling irregularities here this month. So the next one is a week from today at this time. So thank you, and I will see you next time.